Now that you've had a chance to think about which methods you would use, on page 586, there's a chart. And for each of the methods, it gives you when it's the best situation to use it. Um, this is one of those things that you gain by instinct by doing a bunch of problems, but it's also if you want to practice it uh, and get good at making the decision on choosing the best form, uh, you probably want to spend some time reading this chart, but I'm not going to make you memorize it or anything. This is something you will learn over time, even if you don't read this chart right now. Now, the next part that I want to talk about is something called the discriminant. Discriminant, uh, basically, it tells you how many solutions are going to be. It doesn't tell you what the solutions are, but it tells you the number and the types of solutions, which can be pretty handy. If I'm not sure whether or not I want to solve an equation by quadratic formula or by factoring, I can use the discriminant to decide a lot more quickly. And that's kind of the weird thing about what we're doing next. And for some of the problems in your homework, I don't want you to tell me the answers. I just want you to find the discriminant and then tell me how many solutions there are. Now, what is the discriminant? If we take a look at the quadratic formula, the only thing that's really weird in here is the part inside of the square root. That is the discriminant, b squared minus 4ac. That's what the discriminant, that's what we're looking for. If that equals a perfect square, there's going to be two zeros and they're going to be rational numbers. If the discriminant is bigger than 0, there's going to be two zeros and irrational numbers. Stuff like 1 plus or minus the square root of 3 over 5. Stuff like that. That's an irrational number. Usually we put it in our calculator to figure out the decimal form. If b squared minus 4ac equals exactly 0, then there's one solution. And it's usually rational. And if b squared minus 4ac is less than 0, we just say there's no real solutions, or we can say the empty set. And that's the thing where I keep talking about how it's something called imaginary numbers. You learn about those in algebra too. But the nice thing about all of those discriminants and the way you describe them, it also tells you a lot about the graph. If you have a discriminant less than 0, you have 0 intercepts. The graph will never cross the x-axis. If you have a discriminant equal to exactly 0, the vertex is on the x-axis. And of course, the last one, if it's positive, then it's going to intersect the x-axis in two places. So the discriminant also can tell you about what the graph looks like. All right, let's go ahead and use the discriminant on a problem here. Example 4, use the discriminant. State the value of the discriminant, so we actually have to calculate the discriminant, and then we're going to determine the number of real solutions of the equation. So I have 4x squared plus 5x equals negative 3. Of course, it's not equal to 0, so I need to add 3 to both sides. And I get 4x squared plus 5x plus 3 equals 0. And I want to plug it into the discriminant, b squared minus 4ac. Well, we know a is 4, b is 5, and c is 3. Let's plug it in. 5 squared minus 4 times 4 times 3. That's 25 minus 16 times 3 is 48. And you can see there that when I subtract, oh, my 3 looks like a 2 there. 25 minus 48, I get negative 23. So here I would box this. My discriminant is negative 23. That tells me there are 0 real solutions. I don't know what they are. I just know that they're not real numbers. Let's go ahead and try the discriminant out on another example. Let me pull a random one from the book because I want to show you what it looks like in another way. Let's see here. 9-5. Example 4. How about the quadratic 2x squared plus 11x plus 15 equals 0. So it's already in standard form. A equals 2, B equals 11, and C equals 15. So 11 squared minus 4 times 2 times 11. Oh, sorry, not 11. 15 is 121 minus 120. I just multiplied this out of my head real quick, and it comes out to 1. So that tells me my discriminant is 1. That's a positive whole number, or that's a positive number, so that tells me there are 2 real solutions. And if you want to be really fancy, 1 is a perfect square. So that tells me that these are actually going to be rational numbers that are the solutions. And that's how you use the discriminant. I'm not finding the answers, I'm just finding out how many answers there will be.